says write an equation in slope-intercept form, which means y equals mx plus b. So to start off with, we need to subtract 2x from both sides of the equation so that we can move that 2x off of the left side and onto the right side. So we're going to minus 2x on both sides. So when we do that, what do we end up with? Well, we end up with negative 7y equals negative 2x minus 14. Then all I have to do is divide both sides by negative 7 to get rid of the 7 that's in front of y, so that y will be by itself, because that is our goal, is to isolate y. So then we end up with y on the left side and 2 over 7x, and the negatives cancel each other out, so that's our slope. And then negative 14 divided by negative 7 is plus 2. So our equation will be y equals 2/7 x plus 2. And that's how you put it in slope-intercept form. For question number 2, we're asked to find the slope. So let's clear our ink off there so we have plenty of room to work with here. So in this one, we're going to do the slope formula. So we're going to do the first y, subtract the second y, which is negative 7. And then on the bottom, we're going to put 11 minus 16. And so we got to figure that out. Put a little fraction bar in there. So negative 14 minus negative 7 equals negative 7, because that's negative 14 plus 7. And then on the bottom we have 11 minus 16, which is negative 5. And so those two negatives are going to cancel each other out. When you divide two negatives, you get a positive. So our slope is 7/5. All right, so let's keep moving along here. For this next one, we're solving for x, and we know that these are the three angles of a triangle. So very important to understand that. So we're going to go ahead and add the three things together. We got 45 plus 80, and then we've got 8x plus 7. Those are the three things that we're going to add together. So we can line up those 80s and 45 all together because they all go together. So let's get that added up and see what that looks like. So when we combine those, 45 and 80, that's 125. And then 125 plus 7 more would be 132. So we've got 132 over here. And we have 8x over here. And we know that all of that has to add up to 180. Okay. So our next step then is going to be to subtract 132 from both sides. Oh, we lost our 80 there. Minus 132. So we end up with 8x equals 48. And then we just have to divide by 8. And that would give us an x value of 6. And if we wanted to, we could actually use that 6 to go back up here and multiply by 8 and add 7. And that would give us the angle value of that particular angle. All right, so moving along here. So this is part 2 of our linear equation review. And this is where we're going to talk about y equals mx plus b a little bit more and how to apply it. So if we look at this particular example, it says write the equation of the line y equals mx plus b and y equals 2x minus 1. So there's a slope. That would be the slope. That would be the y-intercept. So keep that in mind. The number in front of x is the slope. The number behind x, the b number, is the y-intercept. So using this same format with these numbers that they gave us, the slope is 6. So that number is going to go in front of x, and they're asking us to write an equation with a slope of 6 and a y-intercept of -5. So we use this little template, if you will, and fill in the blanks. And the blanks are the slope and the y-intercept. And there we go. All right, we can do the same thing with this, but in order to fill in the blanks, we have to look on this line and find the blanks, if you will. So the y-intercept, we notice, is where it crosses the y-axis, and that happens to be -2. And then the slope is how far you have to go up and over to get from 2 known points on the line. So we had to go up 2 and over 1 to get from our left point to our right point. So that means that our slope is just 2. So our equation then will be y equals mx, and in this case it's minus b instead of plus b. So y equals 2x minus 2. On our next line, we notice that the y-intercept right here is 1. We had to kind of look at it because they didn't mark it for us. But it's easy to look at the line and see that it crosses there. Now, from that point, if I go down the line, I notice that I cross at another point right here, right here, right here. So I'm noticing that the slope between these known points is just down 1 over 1. So the slope, pretty easy to figure out, is -1 over 1, which simplifies to be -1. So our equation in this case would be y equals -1x plus 1. So that would be the equation of that one. All right, moving along. Write an equation of a horizontal line and a vertical line with a line passing through 1, 8. Well, we don't have a 1, 8, so we need to change that. So let's go to our text here. Let's change that 8 to a 5 instead. Okay, now it'll be a little easier. So when we graph that, we end up with, get my pen here, we end up with a dot over 1 up 5. So we want to write an equation for the horizontal line through there. So we notice that the y value is 5, so the equation of that horizontal line would be y equals 5. Then we want to write an equation of the vertical line that passes through that point. So that would be this line right here. As we can see, that goes to the x-axis at 1. So the equation of the vertical line would be x equals 1. Interesting. Okay. That looks familiar, doesn't it? All right, so now what if we give you a table of values and we ask you to use the table of data to write this y equals mx plus b equation? Well, we know that the slope is the change in y. So the change in y in this case happens to be 2. So that's the number that goes on top right here. And then we have the change in x, which in this case, as I look at my steps here, they're jumping up by 1 each time. So my slope is 2 over 1. Then the y-intercept is found when x is 0 on our table of data. See that 0 right there? So then that means our y-intercept is 4. So then to write the equation, we just write y equals mx plus b. And you don't need to put that 1 on the bottom, so we could have finalized that by saying y equals 2x plus 4. And that would be our final answer. All right, very good. Now, some other words that might mean slope, it could be rate of change, rate of increase, added per day, other things like that. Other words that could, or phrases that could mean y-intercept words are initial fee, we started at, We use the initial fee. What are some other things um, like the shoe fee or something like that if you're going bowling? Or it could be an equipment fee that they have to, or a service call fee if you've got a plumber coming over and they charge you $20 just to show up. And then, so let's put that down there, service fee, so that they can come to your house, all right? So just things like that. All right, now we're going to solve a couple of word problems. So we're going to start by writing an equation and then solving it. And sometimes they might use other letters other than X and Y. So in this case, it says, Donna has 29 cars available to rent. Let C be the number of cars she would have left after renting R of them. So let's go ahead and write that equation. We're going to use the letters C and R here. So we're going to say, here's how many cars she has left. And she started with 29 cars, and she's renting them out. So the numbers that she rents out, we'll just use the letter R, and that can be your equation right there. So cars left equals 29 minus cars rented. And so that would be your equation right up here. So let's get that into the right spot. And then we just take 25 cars and put it in for R. So how many cars does she have left actually? That would be C equals 29 minus 25, which just equals 4 cars left. So you better get there if you want to get a good selection, right? Okay, let's see. I think this is our last problem. We got a road construction crew is lengthening a road. The road started with a length of 51 miles, and then the crew is adding 3 miles per day. So let's let L, so we're going to let L equals the length of the road, total length of the road in miles, and D, the number of days that the crew worked. So this is going to equal, they said that they were adding 3 miles per day, but we started out with 51 miles of road to begin with. So there's our formula that's going to tell us the length of the road from here on out. So then they want to know, well, how long is the road if we've already been working for 32 days? So we just put it into our formula for D right there, as you can see. So there's, and then we figure it out. So that's going to be 96 plus 51. And so 90 plus 50 is 140, and then 6 plus 1 is 7. So our total length will be 147 miles. That's pretty good. That's like going from here to probably south of Nephi, so maybe down to Levan or Scipio, down about that far. That's about how far this road is going to be if you're familiar with I-15. Okay, so there's just a few sample problems you'll see on our ALEKS assignment number 71. Good luck, and if you have questions, let me know. This is a really good thing to practice because I know it's going to show up on the RICE test.